All right, everybody. So we're going to go ahead and take a look at the study guide for chapter one. So math review. Fun. Let's do it. All right. So first off, this problem says a bag contains 8 purple stones, 2 green stones, 5 blue stones, and 1 red stone. Write each answer as a fraction. So here we're looking at theoretical probability. So theoretically, if we were to reach into this bag, what are the odds that we would first choose a red stone? Okay, so I'm going to look at how many red stones there are. And there's 1 red stone. So that is my desired outcome. That's going to be on the top. And then we need to think about what is our total. Well, here I would take 8 plus 2, which gives me 10, plus 5, 15, plus 1, 16. So 16 total options. And then we're looking for that part, that red stone. And so right there, my answer, 1 out of 16. And I showed my work pretty well, right? So we're going to move on to the next one. What is the probability of choosing a blue stone? So I'm going to go ahead and grab my blue color, and I'm going to circle 5 blue stones. That's going to be my part, or my desired outcome. And then it's going to be over my total, just like that last one. 16 is my total. So the probability would be 5 over 16. You could also write 5 out of 16 chance. That's the same thing as what we have here. All right, now we're looking at the final problem. What is the probability of choosing a green stone? So now I'm going to use my green marker and circle how many green stones there are. Well, there's 2, and that's my part over my total, which again is 16. Okay, so we're probably thinking we're all done here, but I noticed that there is a number that goes into both 2 and 16, and that number would be 2. And so if we divide 2 by 2 and divide 16 by 2, then we're going to have 1 over 8 as our new fraction. This is what we would call a simplified fraction. Just an easier way to work with the probability. All right, we are looking for all of your answers in this simplified form. So simplify, simplify, simplify. I cannot stress it enough. Always check to see if there's a number that you can divide your numerator and denominator by. All right, so now we're moving on to the final part of theoretical probability. I almost forgot about D here. If you are going to reach into a bag and pull out a stone at random, what color are you most likely to get? So now we're taking a look at all of the probabilities that we've gathered so far, and we're thinking about, okay, so far we have 1 red stone, 5 blue stones, 2 green stones, and then we see that there are 8 purple stones. Can't forget about the purple. And 8 is the biggest number out of all of them, right? There's more stones that are purple than any other color. And so I would write that as my answer. Purple is the most likely. And now we need to explain how we know. Well, we could say that 8 out of 16, or simplified, 1/2, is greater than 5 out of 16. 2 out of 16, and 1 out of 16. Right? So compared to our red, yellow, and green, I believe that is. No, it's blue. Purple is the biggest fraction. So you could, do something like that where you show it saying that this fraction is greater than the others. Or you could simply just put more purple stones than any other color. All right, so purple would be your best chance if you were to reach into the bag and pull one out at random. All right, now we're moving on to the experimental probability. Right away, experimental, what does that mean? Well, it's like we're running experiments, actual trials, actual data. So it says Dana was collecting data about the pet that the students in her class have. This is the information that she has recorded so far. And so it gives us dog, dog, cat, fish, dog, cat, hamster, fish, dog, bunny. That's a lot of different pets. It sounds like JC's pets that she has at home. I think she said she has 12, if I remember correctly. So first off, we're looking at dogs. How many dogs are there? I'm going to do them in red. 2, 3, 4. All right, you guys see that? 1, 2, 3, 4 dogs. So I'm going to put 4D. I'm going to put how many cats there are. 3 cats. How many fish are there? 2 fish. Hamsters. Can't forget about the hamsters. They're so much fun. 1 hamster. And then finally, 1 bunny. And we'll do that in blue. Using all of our colors here. I love it. All right. So now it says, what is the probability that the next student has a cat? Now, obviously, we don't know if the next student has a cat. There's no way of knowing for sure. But based off this data, we can make an educated guess. All right. So I'm going to take a look at, off the data we have now, how many students have cats. So first off, I'm going to do the same thing as theoretical probability. Find my total. So if I add 4 plus 3 plus 2 plus 1 plus 1, that should be 11. Add them all together. It's going to give me 11. So 11 would be my total. And then we're going to look for parts. In this case, we're looking for cats. And there are 3 cats. So I would say 3, my parts, or you could also say my desired outcome. Over my total, which again was 11. So 3 out of 11 would be a great experimental probability to put down. What is the probability that the next student has a fish? So again, we're going to have our total on the bottom, 11, and then fish. Well, there's 2 fish here. So 2 over 11, 2 fish out of 11 total pets. All right, and can we reduce this? In other words, is there a number that goes into both 2 and 11? I don't think so. So that would be my final answer. Now it is key that we show our work, and I showed my work with different colors because I like to color coordinate. But if you just want to go ahead and list out with letters, for example, or write out bunnies, catfish, just something that shows me that you are thinking in a sense where these are the parts here that make up the entire total. All right, and now we're looking at the probability line. So this is talking about understanding that the probability of an event happens between 1 and 0. So when we think about 1, that's going to be if something happens for sure. You can think about this as 1 over 1, or 5 over 5, or 100 over 100. You could also think about it as a decimal. The decimal would be 1.0, right? 1 is a whole. It is our certain outcome. And then here we're talking about 100% when we think about it in terms of percentages. 100 over 100 would be 100%, or it'd also just be 1 as a decimal. All right, so now that we have certain covered, I showed it in about a million ways. Now we're going to look at impossible. That's going to be our 0. So like if something has a 0% chance, then it's not going to happen. We know for sure. So like flying pigs at the moment are impossible. It would be pretty cool though, wouldn't it? Now we're going to look at what we have here in the middle. This would be 1/2, or 0.5 is a decimal. And then if we multiply that decimal by 100, move that decimal place over 2 spots, then we would have 50. This would be our percentage, meaning out of 100. So these are all 3 ways you can show it, but when you write in fractions and whole numbers, like it's asking, always got to pay attention to what it's asking, we would simply put 0, 1/2, and 1. Fractions and whole numbers is what it's looking for. Now we're looking at, can we describe the likelihood of an event with a probability of 0, 1/2, or 1? And we can think about this again in terms of impossible, equally likely, I'll put EL for that, and then finally certain. I'm going to use a C. So we have I for impossible, C for certain, and E for equally likely. So first, we're going to take a look at what we need to put in these blanks. And we're going to put 0, 1/2, or 1. Okay? So even though these are the meanings, I'm going to put these in the blanks. So the probability of flipping a heads when flipping a coin, well, that would be 1/2, or equally likely. 1/2, right? 1 is your desired outcome, 2 is your total number of possible outcomes, heads and tails. The probability that pigs will be able to fly tomorrow. Well, we actually just talked about that, and unfortunately that's not going to happen. The probability that you will not have any homework for the rest of the school year. I can tell you right now, there is a 0% chance that that is going to happen. The probability that the sun will rise tomorrow. I sure hope it does, or else that's not good news for us. That is certain. I am certain that the sun will rise tomorrow. Ooh, but I don't want to see here. I want to make sure that I write the fraction just like it's asking, or the whole number. In this case, I want a whole number. 100% chance. The probability that you will roll an odd number when rolling a dice. Okay, now I got to think a little bit here. So how many possible outcomes are there on a dice? There's 6, right? And then how many outcomes are even and odd? It's asking for odd here. Well, half of them are odd. If we think about 1, 3, and 5, that's half out of the total. So I'm going to put 3. And then if we reduce this, because 3 and 6 can be divisible both by 3, then I'm going to end up with 1/2. Hey, look at that. That's exactly what we can write in right here. All right, so I don't want to see 3 out of 6 here. I want to see one of our options, 0, 1/2, or 1. All right, now it says I can calculate the perimeter and area of a given polygon. Now, remember, when we look at polygons that are parallelograms, we're looking to solve the same way that we would calculate the area for a rectangle or square. We're going to do the base times the height. Ooh, but I'm not sure which one's the height. This is going up, and this 10 is going up. But think about how we calculate a rectangle or square. Do we take a side that's slanted, or is the side straight up? It's straight up, right? So this is our height. Just like if a person was standing straight up, that would be your height. So I'm going to take 8 for my height, and I need to multiply it by the base. Well, my base, which I'll do in blue, is going to be the bottom. So 13 would be my base. 13 times 8. Well, I know 10 times 8 is 80. So we can do 10 times 8, and that'll give me 80. And now I'm going to do 3 times 8, which will give me 24. So now if I add 80 plus 24, that's going to give me 104. Ooh, but am I done? Let's see what the directions say. Don't forget your label. But I don't see any labels here. I don't see centimeters, inches, feet. I know it needs to be squared, but I don't know what label to use. Well, if it's not given to us, I can always use units. So I'm going to say units with a 2 up above for units squared. Or you could simply put square units. Whatever you want to do, either of these would work for symbol. And then we're going to look at perimeter. So I got 104 units squared. Great. Perimeter, we're actually going to do something a little different here. Perimeter is talking about not what's on the inside, but rather what is around the polygon. So think of area as like the inside of a basketball court, all of the area that a floor covers. And then the perimeter is the out of bounds line. So we want to calculate just the length of the out of bounds line. So since 8 is well within this parallelogram, we're going to ignore it. We don't care about what's on the inside. But we do care about 13 and 10 on the outside. And since this is a parallelogram, what do we know about the opposite sides? Well, we know that they're the same. So 13 across from 13, 10 across from 10. So now if I add all these together, I'm going to do 10 plus 10. That gives me 20. And then if I do 13 plus 13, that's going to give me 26. 20 plus 26 gives me 46. So I can write 46 units. Look at that, I didn't forget my labels. Now we're going to look at the next problem here, dealing with triangles. Now, one thing I always think about when I see a triangle is that it looks like half of a rectangle. Meaning if I were to draw another triangle here, notice these are the same size, right? Triangles 1 and 2 are the same size, and they form a rectangle now. Well, we know that we do base times height to calculate the area of a rectangle. And so here we're going to do the same thing, except since this is half of a rectangle, we're going to divide it by 2 at the end. So my formula would be base times height divided by 2. So let's go ahead and replace first what the height is. Height is 5. And then what the base is, 12. 12 times 5 is going to give me what? Let's see, 5 times 10 is going to give me 50. 2 times 5 is going to give me 10. So that would be 60. And now I need to divide it by 2 because it's half of a rectangle. So I do 60 divided by 2. That's going to give me 30. So for my area, it's going to be 30. Does this one have a label either? No, it doesn't. So again, it's going to be units squared or square units. Just think about it. You could draw little squares in here. You could do 5 up high, and then you could do 12 across. Okay, so now we're looking at perimeter. My perimeter is going to be around. So here I'm actually just going to look at all of the numbers that are around my triangle. So I'm going to take 5 plus 13 plus 12. 5 plus 13 is 18. 18 plus 12 should be 40. 40 units. Oh wait, not 40. This is why we show our work. we're going to do 12 plus 13, that's going to be 25, plus 5, that's going to be 30. And I'm so glad I made that mistake, because on the test, I'm going to want you guys to show your work just like this and double check your answers. So that way you can check and see if you made a mistake. Hey, now we can say 30 with certainty. Now we look at the area, and the area is going to be what we had just talked about. I think we already wrote it down, didn't we? We said it's going to be base times height divided by 2. So we're going to do 12 times 5, which we said was, well, that's how we got 30. Okay. Long day, I tell you. Oh, so these areas are going to be the same as the perimeter, right? Because 5 times 12 is 60 divided by 2. Cool. I'm not losing my mind. They just are the same answer. All right, now it says I can analyze data and make prediction about a given event with the probability. I can create a model to predict the probability of an event. So first off, here's our event. Mr. Nesbitt spins a spinner, and the probability of landing on red is 2 out of 3. So 2 is going to be our top, our part. That's if we get red. And then 3 is going to be our whole, or our total. And so here, we're talking about what if he were to spin it 27 times. Well, would 27 be our whole, or would that be our part? Well, we're spinning a total of 27 times. So that's going to go on the bottom here. And now we have to figure out what would be on the top. So right now our odds are 2 out of 3. And so if I want to change this to out of 27, I would need to say, what am I multiplying 3 by to get to 27? Well, see, 27 divided by 3 will give me that answer. And that is 9. 27 divided by 3 is 9. So if I have to multiply by 9, then I have to multiply my numerator by 9 as well. And so that's going to give me my answer of 18. 18 over 27. Now, typically we would simplify, but this time we actually did quite the opposite. And instead, we wanted to make our numerator bigger because now it's out of 27 times. And so we would just leave it as 18 over 27 and say, you would probably land on red 18 times. So here we're making a prediction based off of the given probability. And we actually did that final part, explain how you found your answer. That reasoning is so important on the test. That's how I know you didn't just write down the answer because you found the answer online or something, okay? So now we're looking at, I can calculate the probability of a compound event. So compound. We just talked about what does a compound word mean, like homework or race car. There's 2 words in a compound word, home and work, race and car. Fun fact about race car, it's the same forwards as it is backwards. But moving on, if compound means more than one, then that means we're going to have multiple outcomes or events. And so when we're talking about multiple outcomes or events, you're going to see these key words here. Or. And it's saying, if we're looking at problem A, spinning a red or a blue. Well, there's one red, and there's also one blue. Well, if we were to say how many parts of the spinner there are total, we would say one red, and then that blue would be a second part. And so now we're looking at 2 over whatever our total is. And in this case, we have 1, 2, 3, 4, 5, 6 parts to this spinner. So my probability would be 2, the parts, over 6. And we get that from 1 red and 1 blue, both 1 over 6. Add them together, and we get 2/6. Kind of messy, but hey, we showed our work. Now we have to think about, can we reduce this? So it is 2 and 6 go into a smaller fraction. Yeah, right? 1 and 3. We divide them both by 2. Now we're looking at what is the probability of spinning a green or orange. So now I'm taking a look at green and orange. I'm going to get rid of all of this stuff I've written. It's a big mess. So we have 1 green and 1 orange. So again, I'm going to do 1/6 plus 1/6. And hey, look at that. 2/6 again. Can we simplify it? You betcha. Divide both by 2. And now we have 1 over 3. What is the probability of spinning red, yellow, or purple? So now we're looking at 1, 2, 3 out of the total of 6. 3 over 6. Can we divide them both by a number? Yes, we can. Divide them both by 3. And now we have 1 over 2. And if you wanted, you could even color coordinate. You could say green and orange. All right, helps me, helps you. Sometimes it's just fun to use colors. All right, now we're looking at 9. Calculate by showing all of your work and explaining your thinking. Adding fractions with unlike denominators. Now, if they had the same denominators, we wouldn't have to worry about changing the denominators. But since they have different ones, we do have to worry about it. All right, we have 1 over 5 plus 2 over 3. How can I change these fractions so I can add them? I got to find what 5 and 3 both go into. Fun way we can do that is just simply do 5 times 3. That equals 15. So that's my new denominator because they both go into 15 for sure. So I'm going to do 3 over 15 because we had to multiply both by 3. And now I'm going to write, instead of 2 over 3, 10 over 15 because we multiply both by 5. So now if I add these two together, if you add red and blue, you get purple. So we have 13 on the top, and then we keep our denominators the same, right? If we eat 10 out of 15 pieces of candy and then we eat 3 more, we're still eating 13 out of the 15 total pieces. We're not eating 13 out of the 30. So that's why we keep them the same. And then move down here, and we'll do this one real quick because you guys really do seem to get this. So I really don't want to spend a lot of time on it. 1/4 plus 3 over 8. And again, we need to find a common denominator. We can do that by looking at what these numbers multiply to, equals 32. So I know 32 is a possibility, but I can actually say, wait, 4 and 8 both go into 8. Right? 4, 8, 12, 8, 16. We already have 8 at the beginning for the least common multiple. So this way doesn't work here. All right, what does 1/4 turn into? Well, that would turn into something over 8. And we multiply by 2 to get to 8. So we multiply 1 by 2, and then we end up with 4. So if we just add across the top, we have 7 over 8. Look at that, and we showed our work, and we circle our answer, so that way Mr. Nelson knows exactly what we're looking for. And then it says, problem 10. I can complete a portions web with a fraction, percent, picture, and decimal. Wow, 4 parts. Okay, so first off, we have 2/5. That would be my fraction. That's taken care of. Now we're looking at decimal. So if I have 2/5, what would that be as a decimal? Well, I could use my calculator, and I could do 2 divided by 5, and that'll give me my answer. But I'm going to wait and get to this in a moment. Now we're looking at percentage. So percentage, I could make this out of 100 because I know percent means out of 100. And so I had to multiply 5 by what to get to 100? Well, I would need 20 nickels to make $1, so I multiply by 20. Do the same to the top. 2 times 20 is going to give me 40. Aha! 40%. And now I can actually figure out my decimal by working backwards and saying, okay, the decimal point would be here. What if I move it 2 places to the left or divide by 100? Then I'm going to have 0.40 or 0.4 simply. Decimal complete. Now I can draw a picture too. My picture could be something like I have a block that is divided into fifths. And then 2 of those blocks would be shaded to show 2 out of 5. Nice. Now we're moving on to, hopefully, what is the last problem? 0.45. So right away it gives me the decimal. I'm going to write it down here. That way we stay consistent. And now if I want to make this into a percentage, we know I can simply just multiply it by 100 because percent means out of 100. And this here we have the tens place, we have the hundredths place. So 45%. If we move that decimal place over 2 spots or multiply by 100. And now if I want to make it a fraction, I know that percent means out of 100. And then I just put 45 up on top. Nice. All right, now 45 out of 100. How do I want to represent this? Well, thinking out loud, my last fraction here was 2 over 5. That was a lot easier to draw. This is going to be tough. 45 out of 100. Maybe I could do something to make it easier. Oh yeah, I could simplify. So 45 over 100 would then turn into what? Well, I can divide 45 by 5 and 100 by 5, so I'd have 9 over 20, which would be so much easier to draw than 45 over 100. So 9 over 20. Okay, so now I could draw a grid of 20. Let's go to 3, 4 pieces across, and then let's go 5 pieces here. Okay, so now we have 20 squares. They don't have to be even beautiful squares, but now we just need to shade 9 of them. There's 4, there's 4, there's my 9th shaded section. And so we should have 11 left over, right? 4, 4, 3, that's 11. Good. So we showed 9 over 20. We checked our work. We showed our work. And so now I think we're all done and ready to go. But before I end, I am going to check and make sure I answered everything and simplified. Let's see, 13 over 15, 7 over 8, 1 over 3, 1 over 2, parts over whole. This time I wanted to go opposite, so instead of simplifying, I multiplied to make it bigger. I got my units. I did answer in 0, half, and 1, whole numbers and fractions. This is also whole numbers and fractions. My experimental probability, looking at parts out of the total, and then same thing here. Nice. So everything looks good to me. I've showed my work. I've double checked it. And so now if this were your test, we would take a picture of it, you would upload it to Canvas, submit it, make sure that I received it. Maybe send an email like, hey, Mr. Nelson, did you receive my test? Just to double check, because it's so important that I receive this on Monday. If you need any arrangements, like you need to pick up the test from here because you don't have a printer, or if you just simply want to write the answers on a lined piece of paper, they both work. Just let me know ahead of time what you're thinking. If you have any other questions about the test, feel free to contact me. You know my email. I release my phone number too to all your parents. It's included on my email. My extension is 3118 if you have any questions. Otherwise, that should be all for today. Good luck. I'll talk to you guys tomorrow if you see this. Otherwise, I'll see this tomorrow. Thank you very much.